Welcome to Snark Chocolate, a show about ZK products, where we break them down with rich flavors and sweet insights. My name is Omer, and I'll be the host for this episode. Today, we're thrilled to be joined by Raphael Ducasse, lead software engineer at Giza Tech. Giza is the infrastructure powering autonomous financial markets by enabling non-custodial algorithmic agents that execute sophisticated DeFi strategies around the clock. Raphael, it's great to have you on the show.
Thank you, Omer. Thank you very much to having me, and I'm really happy to discuss about ZKML, about our agents, and what we do at Giza.
Can we start with a brief introduction? Could you tell us more about yourself and how you came to work at Giza?
Yeah, sure. So, so before Giza, I was working in Revelator, a company, Web3 company in the music industry. Before that, I was at the university doing some work on AI and music, and also I was introduced in the Starknet ecosystem thanks to Louis Gutmann, that you hosted, by the way. I think, yeah. And when ChatGPT was launched, I saw that there was that there's a problem with the integrity of the computation and the integrity of the machine learning model, because when I'm using ChatGPT, I have no idea that they are using exactly the model that I want. So ChatGPT, it can be okay, but for financial products or for healthcare products, it's a problem. So because I was introduced in that Starknet ecosystem, I was starting working on a library called at that time Cairo-ML, and then I was tweeting a lot about what I'm doing and the results that I got with Cairo. And the idea was rebuild from scratch a machine learning model, a machine learning library, but in Cairo, in order to prove the inference. And by tweeting it like Fran from Giza, so my work, and he told me, hey, I'm working on something really, really similar, and building also a ZKML library in Cairo. So do you want to join us? And this is the way that I joined Giza at the really, really beginning. From that time, we made a lot of different trials, and we changed also the way we are approaching ZKML. We are not working with Cairo anymore, but we are still using the Starkware technology called Stu. But I'm gonna talk about that for ZKML library that we are building called LuminAIR. But I'm gonna dive into it later, I'm pretty sure. But this is how I joined Giza, and I entered in that world of ZK and ZKML 2 years and a half ago now.
Fantastic. So actually, I do want to talk about LuminAIR now, because I'm very curious. You've been cooking it for some time and then mentioning it here and there, but yeah, I'd be happy to hear about it from you.
Sure. Yeah, sure. So LuminAIR is a ZKML library. So it's a verifiable machine learning library built on top of Luminol. So Luminol is a Rust machine learning library with an approach that is really similar to tinygrad. If you're familiar with tinygrad, what is it? The idea is they built Luminol to create, to make it easy to add new backend acceleration in machine learning. So, for example, if you want to add backend acceleration like CUDA or CUDA GPU or Metal on top of PyTorch or TensorFlow, it can be challenging because these libraries are pretty big. And the approach of Luminol is to have a very, very small set of operators, only 11 primitive operators to cover any kind of models, from linear regression to event transformers. And then it's focused on compilers. So it's a modular compiler design where we can add other compilers in order to change the computational graph. So machine learning model here is represented as a computational graph, a directed acyclic graph. And the compilers can like change the graph for your own purpose. So, for example, you can have a compiler that will find patterns in your computational graph in order to fuse some operators. And the idea with LuminAIR was to create our own sets of compilers in order to modify a Luminol graph and make it provable with provers, with ZK provers. The first compiler that we are introducing is the LuminAIR 2 compiler. That is a compiler that will take a Luminol graph and connect each operators to AIR components that we are building. So we are building our own AIR with the STU library. And what is nice with LuminAIR is that it's pretty flexible. So at some point, if we want, we can add a new proving system or a new prover really easily, because we just need to support these 11 primitive operators at the beginning. And then we can think about another compiler that will fuse operators to create like more optimized graph, because like if you create a graph of a transformer, for example, or even a machine learning model with only primitive operators, the graph can be huge. But we can have like a compiler that will optimize it. So an example of it, imagine that the compiler will find patterns in the graph, and if it finds like the multiplication operators followed by the sum reduce operator, it can be fused in one optimized operator, like matrix multiplication operator. You see, so this is the idea of LuminAIR, is to be flexible by design.
Are you using some existing technology like MLIR?
No, we are not using MLIR here. Because like Luminol gives us these composable compilers by design, so it was not a need to use MLIR. When we thought about, because before LuminAIR we were building another ZKML library called Orion that was based on Cairo. When we hardshipped Orion with Cairo to think about a more efficient ZKML library, we thought about different ideas, and MLIR was an idea as well. But I think that Luminol, with this approach really similar to TinyGrad, is really simple and tiny library, and it's much easier for also users to add other compilers. You see, we can think, for example, about a compiler for supporting ONNX. And maybe a user may need that, so they can create that compiler, and it will, for example, takes the ONNX graph and convert that graph into a Luminol primitive set of operators, and then it can use the set of compilers that we provide in LuminAIR in order to prove the inference. So yeah, I think Luminol gives us this flexibility that is good enough for us.
So if I package it into a product, just taking one step higher level, so who is it? Who are you aiming for as a user, and what is the pain that you're aiming to solve?
Yeah. So first of all, we built these like LuminAIR for us first at the beginning because we need that. We so as you mentioned in the introduction, Giza is a company that is creating financial agents for Web3 for DeFi, and in we are building like agents for retailers, for protocols, and also for institutions. And all of them have different level of trust assumptions, you know. And if we have to define what is an agent, is at least our definition is a system where you have a part of automation and a part of decision making. And because we have these different actors with different like trust assumptions, first of all, we need our agents to be self-custody. So we have implementing this system of session keys in our agents. For this, the agent execution need to be decentralized. So we are building the Giza protocol for that. But also the decision making needs to be trustless. And we believe that ZKML can fix that. And so first of all, LuminAIR is a way for us to prove the decision making of some of our agents. And the more agents we will have, the more intelligent we will have, the more decision making we will need. So this is for the first use case of LuminAIR is for us for Giza. And then we also built LuminAIR as an open source library, so anyone can use it for their own purpose, not only for agents but for ZKML projects. We are working currently on a project for verifiable recommender system. We are discussing also with a company about proof of liveness for airdrops. So like they can prove that they are humans with a funny way or funny game. So yeah, so this is the idea. We can also we discussed about that in off, but I think watermarking of proving watermarking of AIs is really an interesting use case as well. So yeah, this is.
I want to double click on one example you gave, which is verifiable recommendation system. Can you tell us more about that particular use case and how do you use ZKML for that?
Yeah, so I like I don't want to live in a world where social media platforms or news blog post news websites are like pushing the content that they want us to see, you know. And these platforms have that huge power to share and to recommend the content that they want to see. And the idea of a verifiable recommender system is first, like for example, Twitter 2 years ago, they open sourced their recommender system. But so it's a good first step. But when I'm using Twitter, I have no idea that the feed that I'm seeing is exactly is using exactly the recommender system that they open sourced. So we need this recommender system to be verifiable in order to remove this trust assumption here. So right now we are working with a DeFi blog news website. I cannot announce it right now, but we will announce it really soon. In order to verify, to prove their recommendation system. So at the end of an article, you have like 3 or 4 articles that were recommended, and users on their websites will be able to verify the recommender system. So to ensure that the articles that were recommended is coming from exactly this recommender system that we will open source, and the user will be able to verify it directly on their website. So we implement so in client side and directly from the browser. So like it's a WASM verifier that is verifying the proof. I think it's really, really important. And the idea, we will start with a content-based recommender system. And then we will iterate on top of it and add more complex recommender system with maybe collaborative filtering, etc. And then the idea is to propose that to other protocols, maybe Lens protocols or Farcaster, where I think recommender systems are like at the heart of these protocols. And for me, it doesn't make sense to be a decentralized protocol, decentralized social apps if you don't have a recommender system. If your recommender system is centralized. So yeah, the idea is to develop that narrative as well, because I think it's really, really important for the integrity web, you know.
So you mentioned that currently you are focusing on a compiler to Stew, and I wanted to ask, at what stage are you at the moment? Is it like production ready now that Stew is available? And what's next on the roadmap?
Yeah. So we started with LuminAIR with Stu, as you mentioned. Currently we are at the end of the first phase. So I separated the LuminAIR roadmap in different stages, phases. The first phase was building these primitive operators, the 11 operators. So we need to create a AIR component per primitive operator with two library. There are only two primitive operators that are missing, exponential 2 and log 2. But it's almost done. So the first phase should be done at the end of the month, I think. And then we will enter in the second phase, where we will focusing on, as we said, like creating a compiler to fuse operators. So fusing multiplication and some reduce in matrix multiplication, fusing the addition and the multiplication of -1 in a subtraction operator, etc., etc. Yeah, and this will like create like very more efficient compiler, more efficient operators. When we didn't start it audit yet, so it's not production ready, but you can already build use cases with that. That was also the idea of LuminAIR, is because we have a primitive set. We are starting with these primitive sets of only 11 operators that can cover any kind of models. You can already start building, and then if you need optimizations, we can like focusing on optimizing the graph thanks to the flexible compilers for these specific use case. I think the audit will start it at the middle of the second phase, when we have enough optimized operators and enough use cases also that are production ready. Then we will also, in the second phase, we will also launch the Python SDK, because right now you need to write your computational graph, your machine learning model in Rust. So by launching a Python SDK, I think it will be much more accessible for data scientists and machine learning engineers. And then we also want to do some GPU acceleration using Ingoyama to CUDA. We also, so this will come in the third phase. We also want to decentralizing the verification, the verifier. So why not the verifier is writing in Rust and in WASM. for client-side verification. We are working on an implementation of the verifier in Cairo in order to verify it on-chain on Starknet. And we are in discussion, advanced discussion with LuminAIR to implement the verifier on their network as well in order to decentralizing the verification as well. And then in the fourth phase, but it will come later, we can think about other kind of compilers, as I mentioned, maybe a compiler for ONNX, or different kind of optimizations on different kind of compilers to optimize the graph.
Love it. So I want to talk more about Giza. And one thing that caught my attention is that you recently launched a token. I wasn't aware, but it's good to know. And I'm also, I have no experience with this process, what it involves, and how it looks like on the day-to-day. So would love to learn from you. What changed since you launched? Why did you launch at a given date, and so on?
Yeah. So first of all, I think the motivation between the launch of the Giza token was for the Giza protocol. So we are currently building the Giza protocol in order to decentralizing the execution of our agents. We are creating this protocol with Eigenlayer AVS, and we launched this Giza token for operators. So operators in the context of the Giza protocol is they are not operators, the same operators than the operators in LuminAIR. In Giza protocol, operators are participants to the network, and to participate to the network, they must take Giza tokens. So, and there is a slashing conditions that make the attack economically irrational. So that was like the motivation, the main motivation of launching the Giza token, the Giza token. So we did a TGE. We started in a point system in I think it was in January or December. The idea with that point system was to create incentives with the community. We also launched in December an agent, our first retail agent called ARMA. Now it's not only for retailers, but at that moment it was only for retailers. And so we launched ARMA, and we wanted also to reward our users to ARMA agent, and so we created that point system. We also wanted to reward our contributors from the beginning of Giza. We started Giza as a really open source and developer focused company, even if now we are both. And it was really important for us to reward our initial contributors, the early contributors, and also the current contributors of LuminAIR in our open source tools. And then there is the time to market. The time to market is not an easy decision. I think we are for a year and a half now in a weird timing where we don't know if it's bullish, bearish market. But at some point we had to there is no one perfect date. But so we launched it. I think the most important part when you are launching a token, and but not only a token, I think a product in general, it's the community. And we really took the time to create that community of builders with contributors from the really beginning of Giza, but also now community of users that they are using different agents that we are building. We have two amazing community manager in at Giza, Bartu and Caesar. They are not doing just marketing stuff. They are like really working, talking with the community on Discord. They are like discussing and answering a lot of tickets. They are also like organizing the game nights with the community. So like I think this is like the one of the most important parts is the community. They are really really amazing on that, and we are, as I said, we have also a community of builders. Mostly right now they are building. They are helping me working on LuminAIR, contributing to LuminAIR. And yeah, they are fantastic, and it was really really important for us to uh, to create that community. I think it's the most important part. And then we have the token, so that's nice, but we need to continue to ship and to build and to innovate. As I said, the motivation is for the Giza protocol, so we are building the Giza protocol in parallel, and yeah, we are continuing to ship.
How do I join a game night at Giza?
I'm gonna send you the link. I think they did like a poker night, and they are preparing a new game night soon. So I'm gonna send it to you.
Ah, nice. We love game nights. We talked about the ZKML framework, but you also mentioned agents in I guess the broader context of the Giza protocol. So I want to learn more about your work on agents, how it started, and how it looks like today. Um, I'm also somewhat of a name archaeologist, and while I can understand LuminAIR, which is a great name, the agents framework is called ARMA. So maybe you can start by explaining where the name is coming from.
So ARMA is not the agent framework. It's one of the agent that we are building. We plan to build much more agents. So LuminAIR, where it's coming, so it's the concatenation between Luminol, the machine learning framework that we are based on, and AIR, like algebraic intermediate representation. So this is the for LuminAIR. For ARMA, I think I don't remember when it came from, but I think like we wanted to have a name that sounds like an agent that is short enough. But I don't remember exactly when we found and who found that name. I can find maybe on Slack and tell you. But yeah, so this is the idea of agents. As I said, the idea is to make to have systems that can be that can simplify your interactions on Web3 and DeFi, because DeFi is not easy, and the idea is to simplify DeFi with agents, and to also enhance your interactions with that protocols, do things that you are not able to do with like regular interactions with protocols. The idea of agents came from Fran, the city of Giza, when we were like thinking about use cases for ZKML almost a year and a half ago now, and the more we dove into it, the more we started to build this agent narrative, the more we found that it's a much bigger narrative that we thought at the beginning. So we started to focusing on it and building agents first for ourselves and creating these products like ARMA. ARMA is the first agent that we built. So why now ARMA is for retailers, and we are also now onboarding B2B and like companies and institutions. We just onboarded RE7 Capital to ARMA. Like it's the first institutional like company that is using ARMA now, and then the idea in the future is to let also people like builders create their own agents with the tools that we are building. So we are open sourcing most of the infrastructure, and we will launch later like an SDK and infrastructure with the Giza protocol for letting builders to build their own agents.
So what is the tech stack of these agents? Let's focus on ARMA, which you shipped already. How does it work?
So like ARMA is like an autonomous agent for yield optimization across like different lending protocols. So like unlike traditional vault-based systems, ARMA will like use session keys for self-custody, but also like dynamically reallocating your funds based on the different market conditions. You see? So we are supporting the popular most popular lending protocols like Aave, Compound, Morpho, Euler, etc. And how it's working, so ARMA will continuously observe the APR disparities across different protocols, and will reallocate the capital from like low performing protocols to higher performing ones. And then there is a risk management system that is that prevents the allocation into unstable protocols. There is also wallet level constraints in order to enforce the diversification and prevent excessive concentration in a single protocol, because if everybody that is using ARMA is doing the same strategy, it doesn't make sense. And we do like some gas estimation, like that, for example, ensures that the net yields that you get at the end remain like attractive, you know, after operational costs. For the moment, like ARMA is focusing on yield optimizations for stable coins. In the future, it can be other assets. We are in discussion with that. But like currently, it's optimizing your yields on stable coins. And basically, how it's working, when you like how you as a user, it's working. You go to the ARMA website. I think it's called ARMA, so ARMA.xyz. And you launch an instance of the agent. So like you launch your own ARMA agent that will create a session key for you. So it's a smart account where you have the full custody of your assets. At Giza, we cannot withdraw your funds, and then like you can like specify some constraints about the investment, the kind of protocols you want, the preferences, etc. And then you have like a beautiful dashboards where you can see the APR performance, the real-time rebalancing position, etc. So that's the first agent we are building. We are building another agent that will be released soon, but I cannot share it yet. But I can tell you that it's with one of the biggest DeFi platform. So we are pretty excited about that agent. But yeah, I cannot share more about this new agent, but we are pretty excited about that.
Are you also touching something in the AI layer? Like what kind of AI this agent is using?
No, Euler. Oh, AI or Euler?
AI.
I talked to AI. So ARMA is much more like an agent that is doing some decision making and rebalancing your funds. We have don't imagine that it's a very complex AI model. We are using some machine learning, simple machine learning to do some APR predictions here. But in order to and market trends also, in order to define where we will reallocate the funds. Why now? Even if we don't have the custody of your funds, the ARMA agent is running centralized in a centralized way. In the future, it will be running on really soon. It will be running on the Giza protocol in order to decentralizing the execution. And even in once LuminAIR will be production ready, we will be able to verify these ML part that is doing some predictions on the APR part.
Got it. Okay, so there's one quote that I found which goes something in the lines of 500K in stables managed by Giza agents on base from 0 to $500,000 in 1 week. To conclude this chapter on agents, can you just like explain what it means and how it works?
Yeah, I think we did that. I think we did that tweet when we launched ARMA on base. At the really beginning of Giza, we were launching. We started launching ARMA on mod network, and then we launched ARMA on base. And I think the quote is coming from like when we launched on base, there are like in 1 week the ARMA agent was able to manage 500K USD like USD stable coins from users. I think now is let me find the metrics. I think now we are managing 4.5 million dollars on ARMA. So it's like the total asset under the agent. So yeah, we are pretty excited about that, and we also plan to develop ARMA in other ecosystem, to launch ARMA in other ecosystems like Arbitrum. We are in discussion with Starknet, etc. So it will grow like that. At some point, thanks to the Giza protocol, we will be able to do not only multi-chain but cross-chain. But this will come in the future. But yeah, to answer your question, like I think the quote was the total asset under this agent, under the ARMA agent. In 1 week, it was pretty exciting. In 1 week, people trusted us by putting 500K in ARMA, and now we are managing 4 million and half.
So you're saying it's not a one-time thing. It's like this is how it started, but now it keeps going.
Yeah, exactly.
Right. So in this conversation, we touched upon ZKML framework, LuminAIR, and we talked a bit about agents. And I want to tie everything together. So maybe can you explain to us how these two notions are connected, and in terms of like strategy? How does it how LuminAIR fits into the agents narrative that you are promoting with Giza protocol?
Yeah. So our agents have, as I said, have a part of automation and a part of decision making. And the more use cases we are building, the more intelligent our agent can be. And the idea is to have different level of trustlessness. So we are using session keys for the self-custody part. We are using the Giza protocol for the decentralization, the decentralization of the agent execution, and we are using LuminAIR for the trustlessness of the decision making of the machine learning model of these agents. So these agents will consume the inference result, an inference that is verifiable on chain or in the browser, depending on the different use cases. And LuminAIR particularly is fully open source, so it can be used by other companies than Giza that are doing not only agents but that are doing like pure ZKML or machine learning stuff. But yeah, this is why we built LuminAIR. We built LuminAIR first of all for us in order to remove the most trust assumptions that people can have when they are using agents, and then if there are other pure ZKML use cases, we are happy to help.
That sounds great. Looking forward to see all of that in action and to play with both the agents and LuminAIR. So yeah, I think we covered a lot. So it's a good point to pose. There's one last question which we ask all of our guests, and this is to name a project you are bullish about.
Yeah, I think Bitcoin. I think Bitcoin is the most beautiful protocol and project, and it's the reason why I'm also in that ecosystem, and well, most of us in that ecosystem. So yeah, Bitcoin.
Okay, going for the diplomatic answer. I see. Nice. Yeah. So Raphael, it was great having you here on the show.
Thank you,
I
Omer.
learned a lot. Looking forward for seeing your products live and for more gaming nights. We'll add some links in the show notes for anyone interested to learn more. Thank you again.
Thank you, Omer. Bye.